Welcome back, guys. I do apologize. The last video kind of cut off on me, but that's okay. For those of you who are already comfortable with the previous material and you remember how to simplify these radicals with and without the variables on the inside, feel free to go right ahead and start in on the classwork associated with today's class. In the meantime, I do want to talk about what happens when we do have a variable under the radical sign, because there's something you do need to keep in mind. And so the way I like to look at this is think about a pair. All right, so if you have a pair of shoes, you have two shoes. Or if you have a couple, for instance, couple going out on a date, unless it's a double date, you'll probably just have two people on that date here. So how does that apply to simplifying square roots with variables? So let's take a look at our very first example here. I have the square root of x squared. So in other words, that's basically saying x times x. So how many pairs is that? Well, it's just the one pair. And that one pair, or that one couple, gets to go out on a date. And so our final answer is just going to be x. All right, so let's take a look at another one here. I'm going to look at number 2, for instance. So if I look at number 2, I have 9 times k to the 10th power here. So you'll notice that 9 is a perfect square. So that makes life a little bit easier for us. So if we were to break this apart here, the square root of 9 is just 3. Now, what about that k to the 10th, though, if we're going to break that down? So we could write these out, and we'll have quite a few k's here, as you can imagine. 10 of them to be precise. And I'm really just looking for my pairs, or my couples here. And then if you'll notice, I have 1, 2, 3, 4, and I have 5. And so I would have k to the 5th power. Okay, and so my final answer is just 3k to the 5th power. All right, let's take a look at number 3 here. I have n to the 5th power, which is basically like saying that I have 5 different n's on the inside. And once again, I'm just looking for a pair. Okay. Now you notice I have 2 pairs, 1, 2. And those 2 pairs, they get to go out on a date. Now on the inside, that lonely n, that doesn't get to go out on the date. They have to stay inside. Shame, shame, shame. So if I take a look here at number 4, now they're mixing up a little bit, kind of like what they did with number 2, but you'll notice that 40 is not a perfect square. So we're going to actually have to break this up a little bit more. So let's just deal with the square root of 40 first, okay? So I'm going to have the 2 radical signs since I know that 40 is not a perfect square. I'm going to want to find out what the biggest perfect square is that will go into 40. And strangely enough, my biggest perfect square just happens to be 4. Okay? And then if I were to divide 40 divided by 4, just gives me 10. And just like we did in part 1 of the video, the square root of 4 is 2. And then if I were to do the square root of 10, I would get a decimal. So I don't want that. Now, we're still not done with this problem, because we have to deal with the a to the 19th power. And so that's going to take a little bit of time. And if you notice on my previous examples, I literally wrote them out. And then I just circled my pairs. Now, you could write a 19 different times. But here's a little bit of a shortcut when the number is really big. I could just take that 19. And since we're looking for pairs, I'm just going to divide it by 2. Correct? So if I go ahead and do that, you'll probably notice that if I do 19 divided by 2 in my calculator, I'm going to get 9.5. So that tells me I'm going to have 9 pairs. So those pairs are going to get to go on the outside. So I would have a to the 9th power. But since I have that little decimal there, that leftover a, in this case it would just be one of them, are going to stay on the inside. So I'm going to have 10a. All right. So let's take a look at another one here. If I look at number 5, so you'll notice that 25 is a perfect square. And so that makes life a little easy for us because then we have the square root of 25 is just 5. Okay, that's going to go outside of the radical sign. Now, what about my variables? Now, once again, I can do that little shortcut and divide these exponents here, those little numbers, by 2. So for instance, 6 divided by 2 is going to give me 3. I could do the same thing with the y. And if you notice, if I do 13 divided by 2, well, I'm going to have 6 pairs that come out, but I'm going to have a little bit of a leftover on the inside. So I'm going to have that y on the inside. Now, if the dividing doesn't come to you very easily, you can still write out the different exponents. So for instance, I have 6 x's, and so you'll notice 3 pairs. They get to go on the outside. Same thing with the y's. I could write them. I have 13 of them, so it's going to take me a little bit of time to write these, but let's see. I got 7 here. And now I have 12 altogether. And you'll notice, sorry, 13 altogether. And you will notice that I have 6 different pairs. Those 6 pairs or those 6 couples get to go outside of the radical, out on the date, and then that lonely y stays on the inside. So 2 different ways to do that with the variables. You can actually list them out, circle your pairs that go on the outside, and then the lonely ones stay on the inside. So either or is an option here. So let's do about 2, maybe 3 more examples so that you guys come away with the idea. So if I look at number 6, we don't really have a coefficient here other than 1. So we just have the variables. Once again, I could write out my variables. I could write p 15 different times here and circle all of my pairs. But I think the shortest way of doing this would really just be to divide 15 by 2 and then whatever left over. But in the interest of showing you 2 different ways, I will do that. I'll write out the p's 15 different times. Now, when I do this, I'm going to have quite a few pairs here. And you'll notice I'll have 7 pairs and then that lonely p. So we'll have p to the 7th. And then I'll have that p on the inside here. Okay? Now I could have just divided 15 divided by 2, which would have given me 7 point such and such. And then I would have had the 7, and I would have known there was a leftover p by itself on the inside. With the q, I could write that one out 9 different times. And you'll notice that it looks like I'm going to have about 4 pairs, right? So I'm going to have q to the 4th. Try to squeeze that little 4 in there. And then I'll have that leftover q here. But what about the r? You'll notice that there is no other number that's right next to the r on the paper, but it's just that lonely r to the 1. And so that lonely r has to stay on the inside. It doesn't have anyone to go outside with to play with, unfortunately. Okay? So we'll do 7 and 8 here. So if I look at number 7, I have the square root of 63. Now, since that's not a perfect square, I'm going to have to find my biggest perfect squares. Now, one thing that you're probably going to want to do is write down your perfect squares in front of you so that you have them readily available. You can write them over again on another sheet of paper if you want and keep them because I think you're going to want to reference that. Now, once again, I want to find my biggest perfect square that's going to go into 63. In the interest of time, my biggest perfect square just happens to be 9 here. So I'm going to have 9. And then 63 divided by 9 is just 7. Okay, and so then the square root of 9 is 3. If I were to take the square root of 7, it would just be a decimal. So I'm just going to keep it as so. But I still have that b to the second power, don't I? So I could write it out twice. How many pairs or how many couples do you see? Well, just the one. And then that couple gets to go out on a date. So I have 3b square root of 7. Okay. If I look at 27, same thing applies here. I'm going to have to look for my biggest perfect square. My biggest perfect square in this problem just happens to be the number 9. Okay, once I know that's perfect square, I'm going to put it over to the left here. 27 divided by 9 is just 3. And when I take the square root of 9, I'm going to end up with 3. But if I take the square root of 3, I'm going to end up with a decimal. We don't want that, so we'll keep it like so. And then I have into the third power. I could write it 3 different times, and you'll notice how many pairs do I have? Just that one pair, and that one pair gets to go on the outside. The lonely n goes on the inside. Okay. All right, I want to do just one last example. If you'll notice, problem 9 looks like the last problem that we did on the first video here. We have a number on the outside. And so what we're going to have to do is multiply that 8 here with what we find on the outside. So let's take a look at this one. So we have 320. And so that's a very large number in and of itself here to try to figure out what the biggest perfect square is. Sometimes you're just going to have to take that calculator and just go and search for it. So 320 divided by 16, maybe that's the number. Okay, that works. Is there something bigger than 16? I think so. And 64. All right, so 64 and 5 are my numbers here. So to the left, I'm going to put the square root of 64 and then also 5. Now, the square root of 64 is just 8. If I were to do the square root of 5, I would end up with a decimal. So I don't want that, so I'm going to keep it as such. But don't get confused here, because even though when we simplified the square root of 64 and we got 8, we still have another 8 that's on the outside that we have to multiply by. So 8 times 8 is going to give me 64. Now I'm giving myself a little bit of space, you'll notice, right next to the radical sign, because the one thing we haven't dealt with are those variables. And so we have x, and then we have y to the 4th here. Now, we'll notice that with the x, well, there are no pairs. It's just that lonely x. And that lonely x has to stay on the inside, so we don't need to worry about that. But what about that y to the 4th? Well, if I break that down, you'll notice I have 2 pairs. They get to go outside on the date, so y to the 2nd. Okay. And so there we have it. Okay, so once again, if you have any questions, feel free to reach out to me or Ms. Watkins during our office hours. But it's very, very important that you've watched these videos ahead of time and that you've taken some notes. Also very important, you're going to want to make sure that you've written down your perfect squares. Go as far as you can. That way you should be in pretty good shape depending upon what type of problem that you get here. So once again, this has been Mr. Shields, and look forward to seeing you guys in the next video. Bye.